The point of this problem is to try and understand how percentile locations are calculated. Spreadsheets have their own way of doing it. Statistics software have their own way to do it. So for example, if we plug these numbers into StatKey and we plug them into Google Sheets, we would get slightly different numbers for the first quartile and the third quartile, which are the 25th percentile and the 75th percentile. And the median in the middle would be the 50th percentile. The technique mentioned here, the formula method for finding the kth percentile, is linked in this OpenStax book right here. So I just linked to this book because it was pretty easy to get to. Let's blow this up a little bit. So the formula for finding percentile, let's see, didn't go quite to the right spot. Here we go. For the kth percentile, we have k, which is the percentile, like the 25th percentile, or the 50th percentile, or the 75th. I is the position in the list of the number, and then n is the number of elements in the data set. So first we order it, then we use this formula to find the position, and then we figure out which number or numbers fit that position. So let's do it for this data set. We won't do all of them, but we'll do a couple. So I need those numbers right there. So write them down on paper. Here's my digital paper here. And the median is the 50th percentile. So I'm going to follow this method for the 50th percentile. So median is also called the 50th percentile, which is also the second quartile. So to find the 50th percentile, we first find the location of the number in the list. So locate the number. The trick for the median is to take our percentile 50, write it as a decimal by dividing by 100, then take the number of elements in the list plus 1. So here I have 2, 4, 6, 8, 10, 12. So then I would take 12 plus 1, or 13. So half of 13 would be 6.5. So this is the number I, the position in the list. So here's the first number. They're in order, 1, 2, 3, 4, 5, 6, and so on. So I want the number in the 6.5 position. Now, I can't have a 6.5 position. I can have a 6th position, and I can have a 7th position. And so whenever the list is even, there is no middle number, is what this is telling me here. So I'm going to find the 6th number and the 7th number and average them. So 1, 2, 3, 4, 5, 6. So I want this number and that one. So 60 plus 70 divided by 2 is going to give me what? 130 divided by 2 is 65. So that would be the median here. And that's the one way to do it by hand. Now the median function always works out nice. Q1 and Q3 statistics software packages don't necessarily agree on this, so the by hand method gives a slightly different quartile for most data than a spreadsheet or StatKey, for example. So next, let's try Q1. So Q1, the first quartile, would be the 25th percentile. So the first step is to find the location. That's what we call I. And that would be 25 out of 100 times the number of elements plus 1. So that would be 13. So cleaning that up, that would be 1/4 of 13. And if you need a calculator to do that, go get one. So let's see, half of 13 is 6.5, and half of that would be 3.25. So that's the position. Now 3.25 isn't a whole number. If it was a whole number like 3, I would just say, hey, grab the third number, but it's not. So that means I need to find the third number and the fourth number, and then I'm going to average them. So 1, 2, 3, third number is 33. The fourth number is 41, and then we'll divide that by 2. So, and again, if it doesn't work out to be a whole number, the rule says find the two numbers on either side and average them. Now, this isn't exactly what the spreadsheet does. We can plug this into a spreadsheet and see we'll get a slightly different number, or StatKey, slightly different number for the quartile. Sometimes they agree, but they often don't. So what is this? 74 divided by 2 would be 35, 6, 7. 37 would be our Q1 here. Similar procedure to find Q3. We would just have 75 over 100 times 13. That's the location. And then if that location isn't a whole number, we average the two whole number positions on each side to find the quartile. And so what we're trying to do is just break up the list into these different parts. Now, quartiles and percentiles almost never work out nice. There's always a little tweaking one has to do to find it, and it's not usually exactly a number in the data set. And that's the way it works. So what we're saying is somewhere in here is the position that marks where 25% of the data is before that point, at or before that point. The median ended up being right in the middle here, and then we'd find let's see, get that right spot, I did not. The median is right in between these two. So that would be the median. And then in between, there's probably going to be 3 at the end. Q3 is probably right here, which marks the position where 75% of the data is at or below that point. Let's think about that for a second. Q3 marks the position where 75%, 3/4 of the data is at or below. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers out of 12 below this, at or below this point. 9/12, clean that up. 3 goes in the top 3 times, 3 goes in the bottom 4 times, right? I have exactly 75% of the data is at or below this point right here. So that's where we're making these lines in the sand where we can say, hey, 75% of the data is before that point. 25% of the data is at or before this point. 50% of the data is at or below this point right here, and so on. Percentiles, quartiles by hand. Spreadsheet, again, will give different numbers, but this was just an exercise to try and wrap our minds around what the heck does a percentile mean. It's a position that marks, in this case, where 50% are at or below that point, or in this case, 25% are at or below that point. Thanks for playing.